Good day to Dr. Amri and my fellow friends. We are from SKE2133 Electronic Instrumentation and Measurement, and this video is on PBL2, which is about sensing and data acquisition. My name is Samuel Ng Jian Hao, and my group members are Terence Su Ye Sheng and Lua Jie Yao. The apparatus needed for these experiments are light-dependent resistor, Arduino Uno board, a ruler, wires, a smartphone torchlight, and a lux meter which we use through a smartphone app. So this is the overview of the things we need for this experiment, which is a ruler, the Arduino board, the wires, and the LDR, which is a light-dependent resistor. So this is a clip where we connect the Arduino board with the LDR and we connect it to the laptop. So we connect the VCC pin of the LDR sensor module to the 5V pin on the Arduino board and connect the A0 pin of the LDR sensor module to an analog input pin on the Arduino board. And we connect the ground pin of the LDR sensor module to the ground pin on the Arduino board, and after that we connect it to the laptop. So after we connect the Arduino board to the laptop, firstly we need to go to Device Manager to identify which COM did the Arduino board connected to the laptop. After that, we need to go to Arduino IDE and put in the code, as you can see here, and upload it before we start taking our results. Then we start to record our light intensity results based on different distance between the light source and the lux meter, which we use a lux meter app from the smartphone. After that, we record the reading of our output voltage based on the different distance between the light source and the LDR. So these are the results we got for the light intensity, output voltage, and LDR resistance based on the different distances between the light source and the LDR sensor, and also the lux meter which we use through a smartphone app. So from the data we acquired from the table just now, we plotted two graphs. On the left, there is the LDR resistance against light intensity graph. From this graph, it shows that the LDR resistance is inversely proportional with light intensity, with an increase in light intensity that will result in lower LDR resistance. And on the right, there is the LDR resistance against distance graph. From this graph, the LDR resistance increases when the distance between the flashlight from the smartphone and the LDR sensor module increases. This is due to the fact that the flashlight is set at a fixed light intensity. As the distance from the LDR sensor module increases, the light becomes dimmer, which results in higher output voltage. So from the LDR resistance against distance graph, we find the sensitivity of the LDR, which we can find through the gradient of the graph. So the gradient of the graph we got is 0.2003. Thus, the sensitivity of the LDR is 0.2003 kilo ohm per centimeters, which is also 20.03 kilo ohm per meters. So now we are using LabVIEW to get the output voltage results. As you can see here, now we are setting up the LabVIEW software, and now we modify the delay to 1000 based on the code given. As you can see here, the read buffer shows the output voltage based on different distance between the light source and the LDR. So the result we got from LabVIEW is actually similar to the result we got using the Arduino board just now. So that's all from our group. Thank you.